Good day, everyone, and welcome to this YouTube channel. Today, we are going to solve this paper from the Cambridge IGCSE Chemistry, paper 3 theory, and then, of course, it's a core paper, and then the date is May-June 2023. The paper code is equally there, and the time allocation for the examination. So we are going to be solving all the questions and explaining the concepts so that you can understand why certain answers are so for certain of those questions. So I encourage everyone who watches this to ensure that you share and subscribe to the channel so we can continue to have more good content like this. Okay, so let's go straight into the business of the day. We'll start with the first question there. It says figure 1 shows part of the periodic table, and this is a periodic table already drawn. And it says answer the following questions using only the elements in figure 1.1. It's always good that you read the instructions. It says each symbol of the element may be used once, more than once, or not at all. Give the symbol of the element that, okay, so we have the first question there, is present in diamond. Now, from previous knowledge, you know that diamond is an allotrope of carbon. So diamond is an allotrope of carbon. So if you look at the structure of diamond, you see a lot of carbon atoms linked up. So if you look at the figure 1.1, you see that the element that is most suited to that question is carbon. So we just carbon because this is carbon here. So because diamond is an allotrope of carbon, so carbon is the major element present in diamond. So let's go to the next question. It says, which of these forms an oxide that contributes to acid rain? Now, when we talk about acid rain, is one of the air pollutants that we have. And then remember that is either formed from compounds of sulfur or compounds of nitrogen. So we are looking about the oxides of sulfur, or we are looking at the oxides of nitrogen. These are the two likely causes of acid rain. So when the oxides of sulfur or the oxides of nitrogen dissolve in water, it will form what we call the acid rain. Now if you look at figure 1.1, we do not have sulfur in the figure, but we have nitrogen. So that tells us that the answer in this case should be nitrogen. So just N. Since you're asked to give the symbol, so we're using the symbol of the element to give answers to the questions. All right, so let's go to the next question. It says, as an atom with 5 occupied electron shells. 5 occupied electron shells. Now, from your knowledge of the periodic table, remember that the number of electron shells determines the period of the element. So the number of electron shells determines the period, while the number of valence electrons determines the group. So valence electrons determines the group, number of electron shells determines the period. And remember that the group is the vertical arrangement of these elements on this figure. So this is group 1 vertical, group 2 vertical, group 3 vertical, group 4, like that. So those vertical columns, or we call them the columns that we have on this figure, are the groups. But we are concerned with the number of electron shells, which are the period. So number of electron shells are the horizontal arrangement. So the horizontal arrangement refers to the would give us an idea of the period of that element. So this is a first period, this is a period 1. So this is period 2 because we are looking at horizontal arrangement. So period 2, period 3, period 4, and period 5. So let's go back to the question. It says, which has an atom with 5 occupied electron shells? So which of these atoms is able to occupy 5 electron shells. So we see that there is only a particular element that falls under period 5, and that is iodine. So the I, because it falls under period 5. So we go back there and put in the right answer, because the number of electron shells simply refers to the period of the element. Now let's go to the next question. It says forms an ion with a charge of 1+. Now 1+, elements that form 1+ charge are simply elements of group 1. And just like I mentioned earlier, that the group is the vertical arrangement. So this is group 1, and look at the elements there, which is lithium. So the answer there should be, just go through the figure and look at which element is in group 1. And the only element there is lithium, according to that figure. So we simply put the symbol of lithium here. Next question. Forms an ion that gives a red-brown precipitate on addition of aqueous ammonia. Now, if you remember your experimental design and chemical analysis, when you're doing a test for cations, this is one of the methods that we use to test cations. And if you can recall, it is only ion 3 that will give you a reddish-brown color. Reddish-brown color. So iron is the most preferred here, okay, while ion 2 gives a green color, okay. So ion 3 reddish brown, ion 2 the green color. So ion majorly is the element that would give that property. It's used in the manufacture of aircraft because of its low density. Now this is under metals. When we talk about the extraction of metals, especially iron and aluminium, based on the curriculum, when we talk about aluminium, remember, aluminium is used in aircraft bodies because it has low density and it is resistant to corrosion. So in this case, aluminium, just the symbol of aluminium can be inserted there, and then you've gotten your 6 marks. So you can see how the knowledge of every concept is important in answering this particular question. So I believe that is clear enough. Now let's move forward to the next questions there. It says table 2.1 shows some properties of the halogens. Now we have the halogen in this column, and then we have their melting point in this column, the boiling point downwards, and then the density and temperature. Okay, density at room temperature and pressure in gram per centimeter cube. It says use the information in table 2.1 to predict. The first thing you need to use to predict is the boiling point of chlorine. So let's go to where we have the boiling point. Now, what do we observe about the trend of the boiling point from fluorine to iodine? We see that there is an increase in the boiling point. We're moving from minus 188 to positive 184. That's an increase. So to suggest the value of the boiling point of chlorine, we are looking at values within the range, a value higher than minus 188. So we could say negative, between negative 100 degrees Celsius, at least to give a kind of gap. So we have negative 100 degrees Celsius to about, we could also go as close as this plus 59 to probably plus 10 degrees Celsius. So if you have any value within this range, okay, you would get this question correct. So have values within the range of minus 100 degrees Celsius to plus 10 degrees Celsius. The value must be greater than that of fluorine, and it must be at least closer to that of bromine, to show you that there's an increase in the boiling point as we go down the group. Now, the next question says the density of fluorine at room temperature and pressure. The density of fluorine at room temperature and pressure. Now, look at where we have the density column. You see that it's equally increasing. So the density is equally increasing. So from 0.03 to 3.12 to 4.93. So the value expected for the density of fluorine should be lower than 0.03. So pick any value lower than 0.03. 3. So I could simply just pick my own value and say 0.0009. Okay, because it has to be a value lower than this. Okay, it has to be a value lower than that. All right. Now, the next question, the physical state of iodine at plus 100 degrees Celsius. So we asked to predict the physical state of iodine at plus 100 degrees Celsius. So what information can we get from the table? Let's look at iodine. Look at information about iodine here. Okay, it has a melting point of plus 114, it has a boiling point of plus 184, and it has a density of 4.93. Now you see that this temperature plus 100 degrees Celsius is lower than the melting point of iodine. So at this state, iodine is still a solid because we've not gotten to the melting point yet. Okay, because we've not gotten to the melting point. 100 degrees Celsius is lower than 114. So at that state, iodine is still a solid. Now, reason being that the melting point is higher than melting point is higher than 100 degrees Celsius. So it is until when you get to the melting point, that is when the particles will now lose its the strength of the bond holding it, and then the particles become free to move. But at the point where we are still lower than the melting point, the particles are still very much together. So that is why the reason, that's the essence for this reason. So the melting point is higher than 100 degrees Celsius. So it's still going to remain a solid. Okay, so moving forward, it says aqueous chlorine reacts with aqueous sodium bromide. Complete the word equation for this reaction. Now, chlorine plus sodium bromide. So we look at how reactive chlorine is. In terms of their reactivity, we know that chlorine is more reactive than the bromine in this case, so the bromide ion. So we expect that chlorine displaces the bromide ion in this compound. So we're going to have a product as sodium chloride. So we're going to have sodium chloride here. Oh, okay, let's have it the other way side because there's a space for sodium chloride. Yeah, so we have sodium chloride. Now, sodium chloride is formed because we are looking at a formula like this. Okay, so we are looking at the chlorine molecule coming into the sodium bromide. So what happens is the chlorine is more reactive, so it pushes off the bromide in this case. So it takes the place of bromine here and it forms the sodium chloride, and then bromine remains displaced. So bromine is here. So it's more like a displacement reaction. So that's what is going to happen in that. Since we are asked to write word equations, we basically do not need to write formula equations. But that's just used to explain the question, and you have your 2 marks. Okay, the next question says state a test for sodium ions. Now this is still under experimental techniques and chemical analysis. Now for you to test cations, especially metal cations, what we do is the test is titled the flame. We use the flame test. So we use a non-luminous flame to hit the sodium metal, and then what we observe is the non-luminous flame becomes yellow. So we have a yellow flame observed. So when you have a yellow flame observed, that should tell you that the metal it contains sodium ion, or the metal is sodium ion. I believe that's clear. So you might need to review the experimental design and chemical analysis, test for cations, test for the anions, test for metal ions as well. So look at what are the color changes observed in the flame test. So moving forward, we have this question. It says polluted water can contain harmful substances such as metal compounds, nitrates, and sewage. Name two other substances present in polluted water which are harmful to aquatic life. Now, under chemistry and the environment, we have water, and under that, we have the harmful substances and we have the beneficial substances. So, under the harmful substances, we have metal compounds such as lead and mercury. We have the nitrates, which are from the fertilizers, and we also have the sewage, which are majorly human waste. But we have other harmful substances such as the phosphates equally from fertilizers and some compounds. And then apart from the phosphates, we equally have what we call the plastics. So the plastics equally falls under substances that pollute water. So the phosphate and plastics will get you the 2 marks for this question. So it says state why sewage can cause disease. So sewage can cause disease because it introduces what we call harmful microbes into the water. Okay, it introduces harmful microbes. So harmful microbes introduced to water. So introduced. Okay, it has harmful microbes that is introduced, which can result in typhoid, cholera, and any other sickness. Okay, that relates to bacteria. So sewage majorly introduces harmful microbes that is why it causes disease. All right, so that's for the 1 mark there. So we move to the next question. It says table 3.1 shows the masses of ions in milligram present in 1000 centimeter cube of polluted water. So this is the table 3.1. It contains various ions, cations, and anions. And then the mass of the ion present is also given on this column. So answer these questions using information from table 3.1. Now the first question says name the positive ion present in the lowest concentration. Okay, so we have how many positive ions here? We have the ammonium ion, we have the magnesium ion, we have the calcium ion, we have this, we have potassium, we have sodium. Okay, so let's look at their values. Which one has the lowest value here determines the answer for this question. So we see this 1.2, 2.2, 1.0, 0.2, 6.3, 12.2. So we see that the lowest value here is this 0.2. So it seems to have to name the positive ion present in the lowest concentration. So you can simply write the Ni2 plus, or we could simply say of course, you know that this is nickel, right? So it's nickel 2, high. So nickel 2, or nickel. You could also simply write nickel. All right. So that has been answered. Now, states the name of the ion SO42 minus. So the SO42 minus is simply called sulfate. So sulfate. So there's a difference between the sulfate and the sulfite. So, you know, the sulfate is SO42 minus, the sulfite is SO3 2 minus. So be careful while you pick either of them, depending on what question is being asked. The next question says calculate the mass of calcium ions present in 250 centimeter cube of polluted water. So let's go to where we have calcium ions. Okay, the calcium ions is what we have here. Okay, this is where we have the calcium ions. So remember that the value given on the table is in 1000 centimeter cube of water. So that means we have 2.2 gram in 1000 centimeter cube. Sorry, let me write this properly so that okay, so we have 2.2 gram of the calcium ions in 1000 centimeter cube of polluted water. So the question is asking that calculate the mass of the calcium ions present in 250 centimeter cube. So if there are 2.2 grams in 1000 centimeter cube, how many grams, or how many milligrams rather? Sorry, this is milligrams, not grams. Sorry about that. It should be milligrams. So 2.2 milligram. So how many milligrams are in 250 centimeter cube? So it's simply saying that to get the answer, what we just need to do is 2.2 times, just by cross multiplication, 250, all divided by, this is an unknown, so we can just represent it as x. So x milligram. So 2 times 250, all divided by 1000. So let's see what we're going to have. I think if we do the calculation, so 2.2 times 250 all divided by 1000. Okay, I have 0.55 milligram. So 0.55 milligram. So this is the concentration in 250 centimeter cube. So I could just write 0.55 here, and I have the correct 1 mark for that question. Okay, moving forward, cobalt 2 chloride can be used to test for the presence of water. Alright, so this is how we test for the presence of water. You use blue cobalt 2 chloride, which is dry, and on addition of water, it changes from blue to pink, and is a reversible reaction anyway. That's why we have this. So this is a reversible arrow here. So describe how pink cobalt 2 chloride can be changed to blue cobalt 2 chloride. So it's asking how can we reverse it. So we can reverse this reaction by heating. So just apply heat to the pink cobalt 2 chloride. This water evaporates, and then you obtain back your dry blue cobalt 2 chloride. That is how to reverse it. So that's the process that is required there. So choose a word from the list which best describes pink cobalt 2 chloride. So pink cobalt 2 chloride is a hydrated substance, because it's chemically bonded to water. So these are water molecules, which is simply called water of crystallization. So 6H2O here is referred to as water of crystallization. Okay, so this is hydrated. While in this case, this is an anhydrous. This is anhydrous. Okay, anhydrous. But in this case, the pink cobalt 2 chloride is hydrated. The blue cobalt 2 chloride is anhydrous. Iron reacts with steam to form this compound and a gas which pops with a lighted splint. This information is very important. Okay, that's the information. It says iron reacts with steam to form this, and then it pops with a lighted splint, and a gas which pops with a lighted splint. So the first thing that should come to your mind is, what is that gas that pops with a lighted splint? And the answer is simply hydrogen gas. So hydrogen gas is the gas that pops with a lighted splint. So that means to complete the equation, we have hydrogen gas, because that's the only gas that pops with a lighted splint. While oxygen gas reignites, okay, it reignites a glowing splint. Now, it's important that we balance this equation. There are 3 atoms of iron here, which is balanced. How many atoms of hydrogen here? 8 hydrogen atoms. So what we can do is to simply place a 4 here, and we get the mark allocated for that question. That's as simple as it is. So looking at the information on the question should give an idea of what the answer should be. This is under test for gases, so it's still under experimental techniques and design. So now this is another question. The question is about bromine and compounds of bromine. Deduce the number of protons, neutrons, and electrons in the bromide ion shown. Now, in whether a neutral atom or a charged atom, in this case, this is a charged atom. Okay. Now, whether it is in a neutral or in a charged atom, the number of protons remains the same. And remember that the number of protons is simply the number below here, and the mass number is simply the number above here. Always take note of that. So in this case, like I said, in whether neutral or charged, the number of protons remains the same. So in this case, this is a charged atom, but if the atomic number here is 35, so the number of protons equally becomes 35, because the number of protons is equal to the atomic number in a neutral or charged atom. Now, to get the number of electrons is always the mass number minus the proton number. So the mass number minus the proton number will give you the number of neutrons. Now, in this case, if we do the mass number, which is 81 minus so 81 minus 35, okay, that's 46. So number of neutrons here is simply 46. Now, the number of electrons is what will change in a charged atom, but in a neutral atom. What do I mean by charged and neutral? Let's look at this comparison quickly. This is bromine and this is bromine ion, an ion that's charged. So this is 3581 and this is 3581. So in this first case, sorry, let me write this properly. Now, in this case, this is neutral. It contains no charge. But in the second case, it is charged. Right? There is this charge here. And this charge means it has received an electron. Okay, so in this neutral case, the number of protons is the same as the number of electrons, because it's a neutral atom. But in this case, it is different. The number of protons is not equal to the number of electrons. So since the number of protons is 35, and this negative means it has received 1 electron, so the number of electrons will become 35 plus 1, because the bromine ion has received electron. So the number of protons plus the charge that is on that atom will give you the number of electrons. So in this case, this becomes 36. But in this neutral atom, the number of electrons still remains 35 because it is not charged. Okay, so please take note of these differences. It could help you a lot to understand this concept. So moving forward, it says hydrogen bromide decomposes to hydrogen and bromine when heated. Figure 4.1 shows an incomplete reaction pathway diagram for this reaction. So this is the figure that shows the energy profile diagram of the reaction. Remember, it's a decomposition reaction. Hydrogen bromide decomposes to hydrogen and bromine. So that means the reactant is hydrogen bromide, then decomposition occurs, and then hydrogen and bromine are the product. So it says complete figure 4.1 by writing this formula on the diagram. So 2HBr and H2 plus Br2. Now remember what I said, read from the question. It says hydrogen bromide decomposes. So this is where the reactants are. So we can simply write 2HBr, because this is where we have the reactant. So the reactant will always be here. And then for the product, we can basically write it as H2 plus Br2. So this is what the question was. So this is the product that is formed. This is the composition reaction. This is the product that is formed. So you could write it anywhere you choose. You could write it on top of the line. You need the line. Let's just do it on top, so it's it's not interfering with whatever is here. So this is what you expected to do for this question. Now the next question says, explain how figure 4.1 shows that the reaction is endothermic. Now, for you to know a reaction that is endothermic, remember this is the energy of the reactant. So trace it. This is the value for the energy of the reactant. If you trace this all the way down here, okay, if you trace this is the energy of the product. So this is the energy of the reactant down here, and this is the energy of the product. Now remember that this graph is projecting upwards. All right, so the energy of the product is more than the energy of the reactant, as we can see. So how do we know the change in energy? How do we know it is endothermic or not? We do that the change in energy or the change in enthalpy is the energy of the product minus the energy of the reactant. Now, since the energy of the product is higher than the energy of the reactant, we are going to have a positive change in energy. And a positive change in energy means the reaction is endothermic. Okay, so that is how we know that the reaction is likely going to be endothermic, looking at the energy profile diagram or the reaction pathway. So since that of the product is greater than the reactant, it is going to be endothermic. So explain how this shows, and that's just for 1 mark. So it's just to say that the energy of product is more than the energy of reactants. So just by writing this, you get your 1 mark. Or if you say that the energy of reactants is lesser than the energy of product, either way, it's still the right perspective. I believe that's clear. So the next question says, complete this sentence about an endothermic reaction using a word from the list. An endothermic reaction transfers thermal energy from, the thermal energy is absorbed from the surrounding. So that is how the transfer occurs. So surroundings is the answer to this question. Now, hydrobromic acid is formed when hydrogen bromide dissolves in water. Write the formula of the ion which is present in all acids. Now, the ion that is present in all acids is the hydrogen ion. Okay, so the hydrogen ion is what is present, which is also known as the proton. Complete the word equation for the reaction of any acid with any carbonate. All right. Now, when an acid reacts with a carbonate, 3 products are formed. First, you form the salt. Then you have, of course, it's a neutralization reaction, so you have salt and you have water. Now, because it is a carbonate, you are going to form carbon dioxide. So whenever you have a carbonate reacting with an acid, these are the 3 products that are likely to be formed. So that's as easy as it gets. Now remember, for this question, hydrobromic acid, all acids contain hydrogen. Okay, that's why we have examples of the acids such as hydrochloric acid, hydrobromic acid, sulfuric acid, nitric acid. You see, there is something common here, which is the presence of the hydrogen. So that's why this is hydrogen ion, in case there are any doubts about this. Next question says, a few drops of litmus indicator are added to dilute acid. State the color of the solution. Of course, the color of the solution is going to be red. Okay, this is under the acid, bases, and salts. When you look at the indicators and their colors in different mediums, so it is red for the acid. Okay, so let's move forward to this question. Figure 4.2 shows the apparatus used for the electrolysis of molten lead-2 bromide using graphite electrodes. So we're looking at lead-2 bromide, which is the PbBr2, the molten state. Okay, so it says, the first question says, label figure 4.2 to show the cathode and the electrolyte. All right, now in the structure of an electrolytic cell, remember that there are electrodes, and the electrodes are either cathode, we have cathode and we have the anode. Now there is the fact that the cathode is the negative electrode. So the cathode is the negative electrode while the anode is the positive electrode. So just go to your diagram and look for where you have the negative electrode, which is this, and then this is the cathode. Okay, so if this is the cathode, that means this is the anode. All right, but we are not actually labeled the anode anyway. And then it says the electrolyte. Of course, the electrolyte is simply the solution. Okay, so electrolyte. All right, so we are saying that this would, as an electrolyte in the molten state, it would, decompose due to the passage of electricity. Okay, so it says name the products and state the observations at the positive and negative electrode. So remember, this is the positive electrode, which is the anode. And since it is positively charged, when we split this up, we're going to have something like this, Pb 2 plus, and then we have the Br minus. So these are the ions in the solution. Okay, these are the ions in the solution. Now this is positively charged lead, and this is negatively charged bromine, or the bromide ion and the lead ion. They're two ions anyway. Now the bromide ion is negative, so it gets attracted to the anode. The lead is positive, it will get attracted to the cathode. Now this is what goes to the positive electrode, which is the anode. So the product at the positive electrode is simply bromine, because of course it is a negative, and then it gets attracted to the anode, and the anode is the positive electrode. So if bromine is there, how do we know that bromine is being formed there? You're going to have a brown gas, okay, a brown gas, or brown bubbles, or brown bubbles of the gas will be there. That's how to identify that the bromine has been formed at the positive electrode, which is the anode. Now the product at the negative electrode, of course, we have just the two ions in the solution. So if bromine has gone to the anode, therefore the lead is going to be at the cathode. So lead there. And what are the observations? Okay, you're going to have a gray solid formed. So gray solid will be formed there, and then that's a means of identifying that the metal is there. So that's as easy as that gets. Okay, so state one property of graphite that makes it useful as an electrode. Now, why do we majorly use graphite as an electrode? Number one, is a good conductor of heat, of electricity. Okay, so we could just use good conductor of electricity, unlike diamond. And sometimes it's used because it is inert. Okay, it's inert. So either of them could get you the score, 1 mark for that question. Now, next question says, this question is about metals. Nickel is a transition element. Sodium is an element in group 1 of the periodic table. State two differences in the physical properties of nickel compared to sodium. Now, nickel happens to be a transition element, so that means it has higher melting and boiling point. Higher melting, and it has higher melting and boiling point. So that is one physical property. It has higher density. So higher density is also one of the physical properties. Higher density. Okay, and then you get the 2 marks. Okay, and that's what makes them transition elements, transition metals. They have higher melting and boiling points, and they have higher density. They are stronger. Now, stainless steel is an alloy that is used to make cutlery. Give one reason why stainless steel is used to make cutlery. Of course, because it is resistant to corrosion. Resistant to corrosion. This is under alloys. Okay, resistant to corrosion. So it's resistant to corrosion, and that is why, you know, the stainless steel is made of iron plus nickel plus chromium. All right, so it makes it resistant. That's why we have a lot of elements here combining to, you know, ensure that the metal becomes stronger. We could also say it's stronger. Okay, so just one of the reasons why alloying is done. So resistance to corrosion, to make the metal stronger, durable, okay, as the case may be. Now, table 5.1 shows some information about the reaction of 4 metals with oxygen. So this is the information on the table. We have the metal in one column, and then we have what happens when they react with oxygen. So put the 4 metals in order of their reactivity. Put the least reactive metal first. So look at the information. When gold is reacted with oxygen, there is no reaction at all. When lanthanum reacts with oxygen, it forms a layer of oxide rapidly. So underline this word rapidly, but does not burn. But magnesium burns rapidly to form an oxide. Nickel forms a layer of oxide slowly but does not burn. So these are the adjectives we use to determine the answer. So the least reactive here is the one that didn't give any reaction, which is gold. So gold be the first here. Now after gold, which other one do you think is slower? Okay, which is what? Nickel. So what happens here is nickel burns slowly. So nickel is included here. And after nickel, we have lanthanum, because it burns rapidly, and then magnesium that burns more rapidly. So this is how to give answers. Just by reading the information on the table, you are good to go. So complete the diagram in figure 5.1 to show the electronic configuration of a magnesium atom. Now, check the periodic table. Magnesium has atomic number of 12. So if you are to write the electronic configuration, we're looking at 2 atoms, followed by the 8 atoms, followed by 2. Okay, so this is the electronic configuration of magnesium. So let's draw now. So we have the first shell, which is the first one here, 2. So we could just have 1 and 1 here. So that's 2. And for the next one, we have 8. So we could just have 1, 2, 3, 4, 5, 6, 7, and 8. And then for the last shell, just 2. So 1, 2. And that gets you the mark. So that's how to use the electronic configuration to draw the orbital diagram of magnesium. Now question 6. A student investigates the reaction of magnesium with dilute hydrochloric acid at 3 different temperatures: 20 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius. All other conditions stays the same. Table 6.1 shows the time taken for each reaction to finish. So from your knowledge of rate of reaction, okay, you know the higher the temperature, the shorter the time taken. So look at 45 seconds, 210 seconds, 95 seconds. So this, which of the time taken is the lowest here? 45. Since this is the lowest time here, that means the higher temperature will get us this time taken. So the higher temperature in this list is simply 40. Okay, and then the biggest time taken is 210. The largest time taken rather is 210, and that should be at the lowest temperature, which is 20 degree, and then this should just be 30 degree. That's how to solve this question. So the higher the temperature, the slower the time taken for the reaction to finish, because the molecules will collide more faster and there will be more likelihood of effective collisions. Alright, it says describe the effect on the time taken for the reaction to finish, reacting with dilute hydrochloric acid, and when the surface area of the magnesium is increased. Now you know that when the surface area of a substance is increased, the time taken there will be less time taken. So the time taken increases, so less time will be taken because the surface area has increased. So there are more sites for collision, more sites for reaction. So it takes lesser time. You get the products. Describe the effect on the time taken for the magnesium to finish reacting with dilute hydrochloric acid when the concentration of the acid is decreased. Now that you have decreased the concentration, okay, the effect on the time taken with the time will increase. The time taken will increase because you have decreased the concentration. So the time taken increases. Okay, so time taken increases. All right. Now, describe how crystals of magnesium chloride can be prepared after reacting excess magnesium with dilute hydrochloric acid. Now, this is under salt preparation. So he asks you, just for 2 marks, describe how you would prepare. Now, remember, after adding the essence of adding excess magnesium is to ensure that we may use up all the acids involved. So after adding excess magnesium, the next step is to filter the mixture. So filter the mixture so I can obtain the necessary solution that is the filtrate. So you filter the mixture to remove the residue, then you use the filtrate for further reaction or further steps. So when you filter the mixture, you have removed the excess magnesium that you've added as that goes off as residue. Then the second step is use the filtrate. Now you heat the filtrate to point of crystallization. Heat to point of crystallization. Now it's important that you heat to a point of crystallization and not to dryness, because if you heat above the point of crystallization, you will lose the crystals. So that's why it's very important that you include to point of crystallization. Not just write heat, but heat it to the point of crystallization. Alright, it says magnesium chloride is soluble in water. Choose one other compound that is soluble in water. Now remember, there is a rule for solubility. Okay, all ammonium salts are soluble in water. So this should just give us the 1 mark. Okay, all ammonium salts are soluble in water. Alright, so we move to the next question, which is on organic chemistry now. You're given this structure, it shows the displayed formula of compound E. This is compound E. On figure 7.1, draw a circle around the functional group that makes compound E unsaturated. Now, remember, unsaturated means compounds that have double bonds and triple bonds in between 2 adjacent carbon atoms. So any hydrocarbon or any compound, in this case, organic compound that has double bond and triple bonds in between 2 carbon atoms. Okay, in between 2 carbon atoms, that is referred to as unsaturated. So in this case, where do we have a double bond or a triple bond adjacent or in between 2 carbon atoms? This is where we have it. So we just simply line this and we get the 1 mark. Deduce the molecular formula of compound E. So to get the molecular formula, just count the number of atoms that are involved. So how many carbons are here? We have 1, 2, 3, 4. So we have C4. How many hydrogens? 1, this is hydrogen 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens. So 8 hydrogens. And how many oxygen? Just 1. So that's the molecular formula of the compound. Describe a chemical test to distinguish between a saturated and an unsaturated compound. Now, the test that we majorly use to do this is to use bromine, or we say aqueous bromine water. So adding aqueous bromine water. Okay, so just adding aqueous bromine water, or we keep adding bromine water, the case may be. So when you add bromine water, what will you observe for the saturated? Remember, we said the unsaturated have double and triple bonds, while the saturated are simply single bonds. Okay, single bonds in between 2 adjacent carbon atoms. So in the case of the saturated, what we're going to observe is bromine water is usually orange. So what happens is that the no color change will be observed. Okay, because saturated compounds give no color changes to bromine water. Okay, so no color change is observed. No color change is observed. Let's just stick as let's do this properly. Okay, okay, so no color change is observed, all right, for the saturated, so it remains orange. But for the unsaturated compound, okay, the solution becomes colorless, or you could say that it decolorizes. So it unsaturated compound simply decolorizes bromine water. So decolorizes bromine water. So the orange color changes to colorless for unsaturated. So this is a test to distinguish between an alkene or an alkyne and an alkane. Okay, we just use bromine water. That's under organic chemistry. Now, alcohols have an OH functional group. Write the general formula for the alcohol homologous series. So So for the molecular series of alcohol, we know it's CN, H2N plus 1. Then we have the major functional group, which is OH. So this is the homologous general formula for the homologous series. Ethanol is an alcohol with two carbon atoms in each molecule. So draw the displayed formula of ethanol. So ethanol is, the molecular formula of ethanol is C2H5OH. So drawing this, we have C, then H, H, and then 1, 2, 3, 4, 5. So we've attached the 5 hydrogens, and then we have the OH, so OH. So this is how to draw the displayed formula for ethanol. Alright, I think okay, we should have more questions. So ethanol reacts to form a compound of the formula C6H12O2. Complete table 7.1. Calculate the relative molecular mass of C6H12O2. So how many atoms of carbon were there? 6, and the relative atomic mass of carbon is 12. So 6 times 12, 72. So for hydrogen, how many atoms of hydrogen are here? We have 12 of them. So it becomes 12 times 1, and that is 12. And then for oxygen, there are 2 atoms present from the molecular formula. So 16 times 2, we have 2 times 16, that is 32. So if we add all of these together, let's see, 72 plus 12 plus 32. So again, that's 116. Right, 116. That's the relative molecular mass. Ethanol can be prepared by the fermentation of aqueous glucose. State 2 conditions for the fermentation. There must be yeast present. That is one condition. And then secondly, it must take place in the absence of oxygen. Absence of oxygen, which is also known as anaerobic. So absence of oxygen and the presence of yeast is very important for the process of fermentation. Ethanol can be oxidized to ethanoic acid. Complete the word equation for the reaction of ethanoic acid with sodium. Now, reactions of metals with this. So what happens is we have the sodium ethanoate. As the first product, sodium ethanoate, and then we have hydrogen as the gas or hydrogen given off. So this is more of a displacement reaction as well. Alright, so question 8. Now question 8 is about non-metals. Non-metals are poor thermal conductors. Describe 2 physical properties which are typical of non-metals. So of course they are non-ductile. Remember, metals are ductile, so these ones are non-ductile, and they are equally not malleable, because metals are malleable but the non-metals are not malleable. Okay, we could also include that they are poor conductors of electricity and so on. Carbon dioxide contributes to increased global warming, which leads to climate change. This is as a greenhouse gas. Okay, so state 2 strategies which help to reduce climate change caused by carbon dioxide. Of course, if you remember this under strategies to solve the problem of greenhouse gases such as carbon dioxide and methane. One way is afforestation or planting of trees. So there you say afforestation or planting of trees. And another one is adopting the use of renewable sources of energy. Renewable sources of energy. So instead of burning fossil fuels, why don't we use solar and wind sources of energy to avoid the production of carbon dioxide? The next question, what is a simple molecular compound? Complete figure 8.1 to show the dot and cross diagram for a molecule of water and show the outer shell electrons only. Now, electronic configuration of oxygen is 2, 6. Okay, and we are asked to show only the outer one. So if we show only the outer one, we are only concerned with the 6 electrons here. So let's start by doing 1 will be here, 2, 3, 4. So we've distributed 4, so let's distribute the 6th one, 5 and 6. So we've drawn oxygen. Now hydrogen just has one electron. So hydrogen's contribution here, which forms the covalent bond, is here. So we have, this is hydrogen's contribution. That hydrogen's contribution to bond to form water. It's as simple as that. State 2 properties of simple molecular compounds. Properties of simple molecular compounds: low melting and boiling point. So low melting and boiling point. Unlike the giant covalent structure, so they have low melting and boiling point, and they are poor conductors of electricity or heat, as the case may be. Okay, so that sorts that out. So it's just a comparison between simple molecular compounds and giant structures. What is a good solvent? State the meaning of the term solvent. A solvent is a substance that dissolves a solid. A substance that dissolves a solute. So if you have a substance that dissolves a solute, you refer to that as a solvent. Pure water has a neutral pH value. Choose from the list the pH value that is neutral. pH value that is neutral is simply pH of 7. Okay, that's easy enough. A crystal of blue copper 2 sulfate is placed at the bottom of a beaker of water as shown in figure 8.2. So this is, at first, what we did is drop the crystal of copper 2 sulfate into water, and this is the copper 2 sulfate, and after one day you can see that the color of the water has changed. After one day, the blue color has spread throughout the water in the beaker. So explain this result in terms of the kinetic particle theory. Okay, in terms of kinetic particle theory, it has to do with the movement of the particles. 3 marks. So the first mark is that the the crystals of copper 2 sulfate dissolves. So the crystals dissolves. That's the first mark. Now, as the crystals dissolve, what happens is that diffusion occurs. Diffusion of the particles occurs, or diffusion of the particles occur. And then if diffusion of the particles occurs, as the particles now move from a region of lower concentration to a higher concentration. Okay, so as the particles diffuses, what happens is that the particles mix due to movement, or collision due to movement, or we could say due to collision, which results in the color change, which results in color change. So this is trying to split it into the 3 marks. The first one is that the crystals that was placed in will dissolve. So the crystals will dissolve, and after the crystals dissolve, then the particles will begin to diffuse. Okay, begin to diffuse gradually, and then the diffusion will result in collisions that would now result in movement of these particles to lead to a color change. Okay, so that is I think that is all for this year of this particular paper rather. We'll be doing for extended paper. This is for the core paper for May-June 2023. So I'm going to do extended, and I also include paper 6, which is the alternatives to practicals. So endeavor to subscribe and follow up with other videos. Thank you for watching.